Thanks everybody for attending this webinar. It's going to be a great opportunity to introduce you some of you SEER-IT, as well as kind of get to know how it might be applied in a environment that's not maybe your traditional corporate IT environment. Now, first off, I want to just start off by listing the big picture of the SEER Suite of Applications that Galerath Incorporated. We focus on estimation and estimation applications, and we divvy them up into different domains. We have SEER-SEM, or SEER for Software, that estimates both the application development, integration, and testing, as well as some software maintenance, all the fixing of the bugs, putting in enhancements, adapting the software further down the line. We have the SEER for Hardware, or SEER-H, which is a hardware system, hardware design, development, production, and support model. Now, and I'll talk a little bit more about hardware, but SEER-H is used in the IT context. What SEER-H estimates would be considered very customized types of hardware. We have SEER for Manufacturing, which is a detailed manufacturing view into the cost of manufacturing, looking at different processes and methods. It's an interesting tool, but we're not going to get into it here. And then there's SEER for IT, which, as Kelly had mentioned, is for estimation of the IT infrastructure, deployment, and services. And it estimates both the setup of the IT systems as well as the services and support once they're up and running. SEER for IT complements both SEER for Hardware and SEER for Software, in that it estimates things that the others don't. So they work very well when you can put them together. Now let me just talk a little bit about SEER-H Applications. Now traditionally, SEER-H, or SEER for Hardware, we call it SEER-H for short, has been used for what would be considered custom hardware systems. It's been great for aircraft, spacecraft, missile systems. It also has quite a bit in the area of electronics, and gets down to even estimating custom chips, your ASICs and your FPGA, field programmable gate arrays, RFICs and things like that. So it really gets into very specific, oftentimes very custom hardware, can estimate big picture things, radar systems and communication systems, as well as kind of low-level small pieces of the electronics. In general, you would use SEER-H when you are not just dealing with COTS or off-the-shelf hardware. SEER-H can estimate off-the-shelf hardware. Oftentimes that's a piece of a bigger system estimate. SEER-H is also very much a system-centric model, in that it estimates the key pieces, the custom pieces, say your electronics or custom structures, things like that, but also does the estimation of what it takes to bring these things together. It does what we call our system-level costing, high-level management, high-level integration and assembly, high-level engineering, and things like that. SEER-IT, what you can do is you can couple this. When we talk about systems, and a lot of times systems, you hear the term systems of systems, where you are basically having big picture systems interface with one another. These systems of systems are often interconnected, with IT-based kinds of systems. So this is where the opportunity is to kind of use the SEER for IT to estimate that interconnection of the system. Now, on this next slide, what I have here is a listing of all the kind of estimation elements that you have in the SEER for IT model. These are functional elements. They kind of each focus on sort of a functional area in the realm of IT. Each one of these estimation elements has a set of inputs, has some calculations and rates and factors associated with it, and will compute the labor and the time it takes to either deploy or do these types of tasks or support them. So these are the estimation elements. The ones in the dark blue have kind of internal parametrics with, rates and factors to estimate, number of hours it takes to, set up, servers or set up a database or set up, put together a training package. The ones in green are mainly for kind of pass-through off-the-shelf software or hardware, or we have something called additional items, which is just anything above and beyond what you're not estimating parametrically. So if you can think of these things, these items, as building blocks for an estimate, they can come together with a SEER-IT estimate. And that's my next screen is here. What I have is a sample view of an estimate in the SEER-IT. Now, if you have used SEER tools, this layout will be somewhat familiar. In the upper left panel, we have the estimation elements. Sometimes we call that the project work breakdown structure. And each one of those elements kind of it can be grouped together under summary elements or roll-up elements. So you can organize your estimate in any way you want. Basically, you use the estimation or WDF elements and collect them in different groupings and ways to make up the items in your estimate. Now, for the selected item on the right are the input parameters for that particular item. And those are what drive the estimate, which is what you see down below, just kind of a couple samples of reports and charts that you might have with this SEER-IT estimate. I'm going to get into this a little bit more, but on that quick estimate, you can see a total hours and schedule as well as a cost. Those hours and schedule are broken up into what we call project, which is that upfront deployment time, and then the ongoing support, which is once that system is fielded, what is it going to take to support them for whatever period of duration that you describe or you give it. So let me take this now. This particular example here is a very kind of IT system or IT-oriented type of system. Well, let me introduce this idea of network-centric systems. Network-centric systems basically are the sort of the gluing technology that brings different systems together to share information. Now, the term network-centric systems is typically associated with military systems. Sometimes the term network-centric warfare is used. And again, it's about sharing the information, in this case, between control and the battlefield, in all the sensors of the various systems, be them weapons or communications. It could be, your communications, space-based communications on the ground, and as well as the centralized control center. Now, but these same ideas, and again, the terminology is not completely standard, but the same idea does come up in both commercial and civil systems. They may not be your typical corporate IT types of things, but in the commercial world, anything that oftentimes will bridge your technical product with the business model will kind of be considered one of these types of systems. Let's say if you're providing communication services or phone services, connecting that with the customer accounting so that you can monetize your product. Civil applications, you deal with emergency services, maybe in 911 operations or law enforcement, and bring, connecting with, driving records or vehicle registration records or whatnot. Basically, those tools that they have in civil, applications to get their job done. So network-centric systems, when we talk about it, what are they in terms of what do you need to know and to estimate? Think of it, there's a collection that's going to be hardware and software, as well as a number of processes and systems when they're put together. So oftentimes the hardware is off the shelf, but sometimes, and especially when we're talking about these, you might have something custom. You might have a key card that has an an RF chip in there that is used to identify the person holding that key card. It might be a special camera or a sensor. that keeps track of people or cars going through. It might be, it might be an antenna collecting, certain types of information. So oftentimes it's off the shelf, just like things like your servers and maybe point-of-sale terminals and things like that. But it can be some kind of custom hardware pieces. There's certainly software associated with it, and that will be a mix of maybe off-the-shelf software, oftentimes custom software, custom applications, and there's a term SOA, Service-Oriented Architecture, which is basically kind of an architecture of collection of software services, basically to make it easier for different applications to communicate with each other from a software perspective. That is software, and sometimes it's off the shelf and sometimes it's customized. Those are all things. I put in the term security. Now, security is not just something, you buy off the shelf or you put in there. Oftentimes the idea of security is blended in with the software that you're implementing and possibly the hardware, as well as procedures and things like that, but certainly consideration with these types of systems. And then there's a collection of basically how things interface and procedures and how things will be up and running. So oftentimes, so the question is, how do you go about estimating these things? Now, some things might be a little bit easier and straightforward, some things may not. Well, like any estimate, the first thing is to, break it down. What do you have? What are the tangible physical items? What are the somewhat tangible but soft items, such as your software, your databases, things like that? What are procedural? What are things that are, happen one time versus recurring? Also, and this is kind of estimating 101, is consider the life cycle. What needs to happen when? What do you need to include in your estimate? Oftentimes there's that upfront design and engineering of the system. Sometimes there's custom design and mention, what if you have an RFID card that you need to design for a system that goes out to, to end users or customers or whatever. That may need to have some special componentry design. You might have custom software that needs to be designed. So there's that upfront kind of engineering effort that needs to take place. Once all these things are quote-unquote designed, they all need to be implemented. They sometimes you're dealing with not just a centralized location like a control center, but it may be things that go out in the field at, maybe a dozen locations, maybe 100 locations. So you have basically the setup of these things in deployment, which is not original design like building from scratch, but once you get these servers and you have all the software, it needs to be set up, the software needs to be installed, needs to be gone through a full complement of test and checkout. And then once you're ready to go live with it, the system needs to be supported. You don't just switch it on and it goes forever. People need to stay on top of it. You need database administrators and system administrators. You need people to make sure they do proper backups and system maintenance. You need people to manage, user accounts and users on the system. So it's, once you have it deployed, there is what I would call care and feeding of the system. So the next part I have kind of a breakout of the different pieces of a network-centric system and what various tools you would use and when. So if you look at the rows here are kind of different key elements of the system. The columns are basically that upfront development that you might have. The middle column is the implementation. Sometimes that's called deployment or fielding, and then the ongoing support. Now, the first thing I have is what we call systems engineering, and systems engineering is basically that kind of big picture design and engineering to make sure you have the idea of what the major interfaces are, how things are going to come together, will things perform as expected, are we buying enough servers to get the bandwidth that we need, and so on and so forth. So Now, for systems engineering, you can use SEER-IT. We have a systems engineering model. In particular, it's a COSYSMO implementation that you can use to estimate that upfront systems engineering. On the software side, for, say, custom software and all the services, the SOA services, your web services, and things like that, which oftentimes make up the backbone, at least the software backbone of a network-centric system, those can be estimated. The actual design of them and the development can be estimated with SEER-SEM, and then the deployment or the implementation can be estimated with SEER-IT. And then I'm going to sort of have both SEER-SEM and SEER-IT. SEER-SEM would be used for any sometimes what's called break fix or software maintenance, either fixing bugs, adapting the software, say external interfaces change. And then SEER-IT can be used for just the standard ongoing support operations, backup, update, troubleshooting and things like that once it's up and running. COTS hardware and software, assuming that you're just using things off the shelf with no special integration, you can estimate the implementation with SEER-IT as well as the ongoing support. Now, custom hardware, this is where you can involve SEER-H. Let's say you have a RFID or you have a sensor, or you have maybe a special communications module. That can be estimated with SEER-H. The implementation and the integration can be a combination of SEER-H and IT. Now, the ongoing support, i.e. the maintenance, which may have special repair or remove and replace procedures, can be with SEER-H. There's a few other things I have listed here: training, documentation. All those things can be estimated with SEER-IT. Repositories and security. Talk about original design and development of those. If there's special software, that can be done with SEER-SEM. The implementation and support with IT, as well as the facility. SEER-IT can cover facilities. So you can see really what you want is sort of the right tool for the right piece. And again, they can all, they're very complementary of one another. Now, one thing that when we estimate something with say, SEER for hardware, we do estimate the design, development, as well as if there's any special production or manufacturing. That can be done. But if you actually want to take that item and put it out in the field, you can use SEER for IT for that. Now, this term fielding, sometimes it's called, if it's purely a software environment, sometimes it's called the implementation. Sometimes it's called fielding, meaning putting the systems out in the field. All that includes basically planning for the deployment, the procurement of the COTS, configuration of the development and production systems, and all the test and checkout of those systems, as well as all the training. That's done all under kind of the SEER for IT. In fact, what you have here, you can put together a little life cycle schedule of what the major phases and milestones are. This example kind of shows one happening right after the other. They don't have to be that way. They can be done in parallel as well. Now, support of the network-centric system. As I mentioned before, once you have that system out there, you don't necessarily just turn the switch on and let it go. There's got to be a lot of people to do what we call the care and feeding of the system. You've got system administrators, database administrators, technicians, as well as people managing all these. Depends on how big it is in terms of how many people you would need. This is often called sometimes IT services or infrastructure services, service management. The terminology kind of varies from organization to organization. But in the context of SEER for IT, this is what we call the operational support, or what we call ongoing support. And in SEER for IT, we consider the duration, basically, how long are you going to support it for. We would consider oftentimes the growth of the user base, or sometimes the turnover of the user base, how often things are being upgraded, as well as something called the service level agreement, which is basically how well supported is the system? And that oftentimes can correlate with how critical the system is. Obviously, if it's a super critical, can't have any downtime, you need some of the highest level support to turn around issues and problems very rapidly. If it's not so critical, you don't need to give it quite as much attention. Now, also for hardware types of things, we also look at attrition rate, useful life. How often do you, replace a PC or a server, as well as how often do you do any kind of scheduled maintenance. Now, I have an example here. This is an example of a network-centric system that we put together. It's kind of a notional example that has basically these pieces of the estimate in terms of that high-level engineering, putting together all the infrastructure services, as well as integrating some custom hardware in it. The key components in the example, we call this a Network Centric ISR, Intelligence, Surveillance, and Reconnaissance System. I called it CabNet, just a made-up name. 4 key components of the estimate. I mentioned that systems engineering, and I'll show you how we use the COSYSMO model to estimate the systems engineering. We have the deployment and support of all the enterprise services, which is all the software and databases and how in middleware and how they come together to provide all these IT services. We have the hardware, the data center hardware and facilities, as well as there's a remote setup, a remote location. So we've included that here. So all the development and integration of the software can be estimated with SEER-SEM or SEER-IT software. And then the procurement and integration of maybe platform-specific centers is done with SEER-H on there. Now the systems engineering. This was that first element on there. We have an element in SEER-IT called Architecture and Design, and what it is it has the COSYSMO model. COSYSMO was a model developed out of USC Center for Software and Systems Engineering. It actually, we have an update, most recent update, it's not in the screenshot, that includes not just what the drivers are, but reuse of these. So the key drivers look at the number of requirements, the number of interfaces, your operational scenarios. The way we do things with SEER, everything is always described. You have 3 inputs, least likely most, so you can take advantage of those ranges and uncertainty. And also, like I said, it's not shown here, but we now have a reuse model. So maybe you have an existing interface that you're adapting or you're modifying. You can take that into account into the estimate so that, obviously something if it's not brand new may not take quite as much effort. Now the enterprise services. The enterprise services are all the, essentially the software services that the system needs to provide. Deployment of these services can be done with SEER-IT, and it covers all the things associated with implementing your enterprise applications, all your core services such as web services that you need to set up, messaging services, as well as databases. This is just a kind of a detailed list of all the things that SEER-IT covers in its estimate. The degree to which it covers will depend on the key input drivers, for instance, database setup. Depends on how many new or existing databases you might have, the size of the databases in terms of number of tables, applications, what kind of architecture you have. Is this all if there's a client's piece to it or not? All that kind of comes together based on your input drivers, and these are the things that are covered in the estimate. Infrastructure services, in the IT world, this is the hardware. These are essentially your servers, your network components, all your routers and bridges and firewalls, as well as it could also include end-user terminals, PCs, PDAs, things like that. Anyway, for infrastructure services, we're actually talking about mostly server and network, and the estimate will cover, all your planning, capacity planning, your configuration management, the documentation of the system, and the setup of the system, as well as all the test and checkout at a server level, at a network level, and an overall system test. Other hardware, your workstations and things like that. SEER-IT covers the deployment, test, and checkout of all those end-user systems, as well as the distribution. If you have to talk about, putting out hundreds or dozens of types of things, that will be included. I didn't list it in detail here, but oftentimes there might be a facility component. You may need to run cables. You may need to put in fiber lines. Things like that. We have a facilities model to cover that. Now, oftentimes hardware, if it's purchased, if it's off the shelf, you just include that in the SEER-IT estimate. You can tie it to a database so that you can include in your catalog, whether it's a software catalog or a hardware catalog, in terms of the types of things you want to include in your estimate, or you can just put them in directly. This example here, we've got this Microsoft catalog in there as an example. So you can put in the types of applications and what it is and what it costs there, as well as support costs. Now, custom hardware, we talked about what if the system has, special sensors? What if it has an RFID? Well, that type of thing you can estimate in SEER-H, but you can bring that into your SEER-IT estimate. You can use that as kind of a, sort of the place where you can combine the estimates. And we do this quite a bit with IT and software estimates, but the same thing can occur in IT and hardware estimates. And we have a special item called additional items that can be used to include those types of things. And you have the ability to put in both, how many quantities, labor hours, and or material costs. So you can put in a labor component as well as a material component in there, and then just tie that to whatever activity and labor grouping you want to include that, and that will become part of your estimate. Once you have these things all together, the SEER-IT provides kind of a very rich reporting environment. Has estimates by activity, phases. It also does risk analysis. It will look at a roll-up of your Monte Carlo analysis to look at what the cost is, where the schedule is at a summary level. You can look at your time-based reports, as well as resource headcount requirements in here. This chart in the lower left will show what you need up front to deploy the system, and then once you go into ongoing support, what kind of a headcount you need to support that system. Now, I have one more just quick example to show you, and again, this is just to illustrate, here's a system that does not look like your typical IT system. This is an example, if you've ever driven on some of the newer toll roads, where you have maybe a special path in your car, and as you drive through these toll things, it basically reads your easy path, I think is a term, or it's got different names, but reads the easy path, and somehow it knows that you use that toll road and it credits to your account. Or depending on what kind of account you have, all you can drive or per passage, it will, bill you accordingly. So this type of system, obviously, you've got something out on a toll road, you've got the toll booth, you've got the RF reader that reads your tag, so you have some very specialized hardware there. You also will maybe have some optical systems that will take pictures of the cars that maybe just crash the gate so they can get your license plate number on there. They have, also, and what's not seen, is all this data gets passed through to a network connection to some sort of data center that reconciles, your passage with accounts and does all the billing. So all this can come together in the context of a SEER for IT estimate. In this case, I've got on the right the shot of the work breakdown structure where you have the high-end systems engineering, put this all together, and you can describe all the interfaces and requirements and things like that need to be evaluated. You will have custom software. There may be a couple custom applications, and you can use SEER-STEM to estimate that. And then you can estimate the data center, which would be both your infrastructure hardware, setting up the servers and things like that, as well as setting up the applications and the databases that run at that data center. And then you have the remote location. In the remote location, you've got your cameras, you've got some sort of workstation probably there that serves as a conduit to send out the data, probably has some sort of software on it. You've got the network connection there that connects that remote location to, the network, as well as, the various road sensors and cameras and things like that. You can also put in, let's say there's special travel that you need to include, 5 trips out to the remote locations for, 6 engineers. You can include that in that, as well as purchasing of any of the off-the-shelf. Maybe the camera and the servers and things like that are just off-the-shelf. Those can be included in the estimate. So here is, again, a non-traditional corporate IT type of system that you can use SEER for IT with a little help from SEER-STEM, with a little help from SEER-H to do this. Also, these types of special sensors, again, SEER for hardware, if you have to design any RFICs and things like that, that can be part of your SEER-H estimate that you can either do standalone at SEER-H or bring that estimate into SEER for IT. And I think this is just what I had described in this slide. So at this point, I guess if there's any questions, I'd like to open it up for any questions.